Okay, example number 3 is another question that I found off of an old Algebra 2 Trig Regents exam. So let's go through the givens. I've drawn the picture as best I can. It tells you that side B to D is 10. So B to D is 10, that's going to be lowercase b. A to G is 15, that's going to be lowercase b. B to E is 6. F to E from here to here is 10. The measure of angle ABG is 40 degrees. It tells you that the measure of angle GBD, this angle right in here is 90 degrees, so there's a little square there to mark that it's a right angle. The measure of angle C is less than 90 degrees, so that's going to be an acute angle. We're also told that B to E is congruent to E to D, so this segment and this segment are congruent. So if this piece is 6, this piece is also going to be 6. And it tells you F to G is congruent to F to B. F to G, this is congruent to F to B. Okay, so first thing we have to do is find the measure of angle A. If you take a look at this top triangle, we can find this whole side from B to G. So Pythagorean triple 3, 4, 5 is a Pythagorean triple, you know, but so is any multiple of that. So if you multiply every one of these sides by 2, 6, 8, 10 is also a Pythagorean triple. So this side is, this is a right angle. So this side would be 6, this side would be 8, and the hypotenuse of that right triangle would be 10. Or you could use the Pythagorean theorem to find that side. Because these two pieces are congruent, this side is also 8. So the whole side from B to G is this 8 and this 8, so that whole side is 16. So to find angle A, I redrew this top triangle. We just figured out that this side is 16. To find the measure of angle A, this would be my lowercase a in this triangle. I'm going to use the law of sines. So A over the sine of angle A. I know side B over the sine of angle B. Cross multiply for the sine of A. Once you work that out, get your reference angle by doing inverse sine with your answer, and the measure of angle A turns out to be a 43.3 degree angle. Okay, so that's how you run through the first part of this question. To do the second part of the question, we have to find the length from B to D, which in this small triangle down here is lowercase d. That's what we're looking for. So I'm going to redraw just the bottom triangle. Angle D, angle C, angle B. This is 10, lowercase b. We know this whole side was 6 plus 6, so lowercase c is going to be 12. We can find the measure of angle B up here. A straight line is 180 degrees, 180 minus 40 minus 90. This angle B right here is a 50 degree angle. So I'm going to put that down here into my picture, a 50 degree angle. So what we're trying to find eventually is the side D. With what's given right now, I could find the measure of angle C using the law of sines. So first thing we're going to do is find angle C. Using the law of sines, C over the sine of angle C, I know side B over the sine of angle B. Cross multiply for the sine of C. Follow my notes. Do inverse sine when you work that out to be a decimal. Then you have the measure of angle C. After you have the measure of angle C, the measure of angle D is going to be 180 minus the 50 degrees for angle B minus your unrounded answer for angle C. Measure of angle D turns out to be about 63 degrees. Once you have found the measure of angle D, to find side D, you could use the law of sines, but you could also use the law of cosines. So finding side D using the law of cosines, I would start the formula with D squared equals. The other two sides of my triangle are B squared plus C squared minus 2. These sides to the first power, B times C times the cosine of capital D. Remember, the angle over here and the side over here have to match. Use your unrounded value here, and then you can find the length of side D. Then the end of these notes are just a summary of when you use the law of sines, when you use the law of cosines, and area formulas for a triangle. So I hope that this is helpful, and I hope that you guys are all doing well, and I hope you're having a great day, and I look forward to seeing you again soon.